Encryption is a technique that converts information into an unreadable format to protect its confidentiality. Complex mathematical algorithms are used to transform the data into an encrypted form. This ensures that only authorized people who have a key or password can access the information. Encryption is used to guarantee the confidentiality, integrity, and authenticity of the data. It helps protect sensitive information in various situations, such as online communications, sensitive data, storage, password security, and digital authentication. The main encryption methods are symmetric encryption and asymmetric public key encryption.
Asymmetric key cryptography, also known as public key cryptography, uses two different keys at each end of the communication to encrypt and decrypt it. Each user in the communication will have a public key and a private key. The private key needs to be protected and kept by the users themselves. It should remain secret and not be known by anyone else or sent to anyone. The public key will be accessible to all the users of the system who want to communicate. The strength of the system that ensures the security of this type of asymmetric algorithm is based on the mathematical functions that are easy to solve in one direction, but extremely difficult to solve in the opposite direction, unless the key is known. The public and private keys are generated simultaneously and are linked to each other. The relationship between them must be very complex to make it extremely difficult to derive one key from the other. In this case, deriving the private key since the public key is known to everyone connected to the system.
Symmetric encryption. Also known as a secret key encryption, it uses a single key to encrypt and decrypt the data. The same key is used for both operations, the encryption and decryption. The sender and the receiver must share the same key before communicating. Once both parties have the same key, the sender will encrypt the message using this key and then send it to the receiver, and the receiver decrypts with the same key. Symmetric encryption is faster and more computational efficient than the asymmetric encryption, but it presents the challenge of how to secure, share, and protect the secret key.
Classic encryption and transposition are two cryptographic techniques used to protect the confidentiality of information. Classic encryption refers to the encryption methods used before the advent of computers. Some well-known examples are the Caesar cipher and the beginner cipher. These classic ciphers are relatively simple and are considered insecure today due to advances in cryptanalysis and modern computing power. Classical cryptography also includes the construction of machines, which, through mechanisms commonly composed of gears or rotors, transform a plain text message into an encrypted message, such as the Enigma machine used in World War II.
Transposition is an encryption technique that involves to change or rechange the order of the letters of one message. The content of the letters is not altered, but the order is changed. This type of encryption is based on the idea that the order of the letters is important to understand better the message. Transposition alone does not provide very strong security, but can be combined with another technique of encryption like substitution, and this can increase the security system.
Digital signature is a cryptographic method used to authenticate the integrity and authorship of a message, document, or other types of digital content. It functions similarly to a traditional handwriting signature, but relies on cryptographic techniques to ensure the authenticity of the signature and the integrity of the document. In its early days, digital signature relied on symmetric key cryptographic systems, where both the signer and verifier share a secret key to encrypt and decrypt the signature. As digital signatures gained acceptance, standards and algorithms were developed to ensure interoperability and security. Some examples of these standards include the X509 standard, which defines the format of digital certificates, and the RCA algorithms widely used for key generation and digital signatures. Public key infrastructure, or PKI, was developed to facilitate the widespread use of digital signatures. PKI provides a framework for the secure management of public keys and digital certificates. With PKI, trust entities known as certification authorities (CAs) enable reliable verification of digital signatures. Advanced digital signatures can include additional features such as timestamps to provide evidence of the signing date and time, and batch signatures that allow multiple documents to be signed in a single operation. Blockchain technology has introduced a novel approach to digital signature by leveraging the decentralized and immutable ledger features of blockchain. Verifiable digital signatures can be created publicly and transparent. Digital signature continues to evolve to adapt to technology advancements and emerging security challenges. New techniques, standards, and approaches are still being developed to enhance the authenticity, integrity, and non-repudiation of digital documents.
So finally, in conclusion, we can say that encryption is the method by which information is covered into secret code that hides information through meaning. Science of encrypting and decrypting information is called cryptography. Encryption has been a long-standing way for sensitive information to be protected. Historically, it was used by militaries and governments. But in modern times, encryption is used to protect data stores on computers and storage devices, as well as data in transit over networks. Symmetric encryption is the use of a single key to both encrypt, encode, and decrypt the code data. The key we are talking about can be either a word, a number, or a string of letters. On the other hand, asymmetric encryption is the process of using a public-private key pair, public key to encrypt plain text, and then using the corresponding private key to decrypt the encryption. Some examples about decryption are websites that transmit credit card and bank account numbers encrypt this information to prevent identity theft and fraud. Other could be the authentication, digital signatures, timestamping, and finally encryption in WhatsApp.